Hi students, now we will discuss about the relative velocity in depth. Listen carefully. So before we discuss about the relative velocity, I just summarize the parallelogram law. Parallelogram law, that is here this P and Q, these are the two vectors and the angle between them is theta. So the resultant vector is the diagonal that is represented by the vector r. So r represents the resultant of P vector and Q vector. If the magnitude of vector P is small p, magnitude of Q is small q, and magnitude of r is smaller, then from the parallelogram law we know r is equal to p square plus q square plus 2pq cos theta. And also here alpha is the angle between the resultant vector r with this p. This alpha represents the direction of the r. So we can prove, I hope this already have discussed in your previous classes. The tan alpha is equal to q sin theta by p plus q cos theta. So from this expression we can write alpha is equal to tan inverse, that is q sin theta small q. Q sin theta plus p plus q cos theta. Alpha denotes the direction of what? The resultant vector r. Now we use this parallelogram law to calculate the relative velocity. Now just see here. Here the two person A, VA is the velocity of person A and VB is the velocity of person B. Two person A and B, A person is moving with velocity A and B person is moving with velocity B. And their direction VA is along this direction and VB is along this direction. Now in this situation, if person B observe the person A, then the person B cannot feel the actual velocity of A. The velocity which is observed by the person B, that is the relative velocity of A with respect to B. So here if the person B observed A, then that observed velocity is the relative velocity of A with respect to B. Now if you extend this VB is actually along this direction, if we extend this VB opposite direction, so that will be the minus VB as the vector rule. So this is the direction of VA and this is the direction of VB. And at first the VA and VB, in between them the angle is theta. The VA and VB, angle between them is theta. So what is the angle between VA and minus VB? That will be 180 minus theta, because this total is 180, this theta, so remaining portion is 180 minus theta. Now if you apply the parallelogram law, then this is the diagonal and this diagonal will represent the relative velocity of A with respect to B. The relative velocity of A with respect to B, this diagonal will represent, and that is defined by the terms VAB vector. Now if you calculate the magnitude of VAB, that is the magnitude of the relative velocity of A with respect to B, and if we calculate the direction of VAB, that means the direction of the relative velocity. So at first, here we denote that minus VB, this minus VB has the magnitude what? That is small VB. The magnitude of VA vector, that is small va, and the magnitude of the VAB, that is relative velocity vector, that is small VAB. So now if you apply the parallelogram law, this formula, if we apply, so here you can write VAB is equal to VA square plus VB square plus twice VA VB cos 180 minus theta. Why? Because the angle between VA and VB is 180 minus theta. That's why at the place of theta we put here 180 minus theta. Here the angle between VA and minus VB is 180 minus theta. That's why here we put 180 minus theta. Now after that, VAB is equal to VA square plus VB square plus twice VABB cos 180 minus theta means we know the minus cos theta. So here we put minus cos theta. And VAB is equal to, now we can write VA square plus VB square minus this minus and plus minus, so minus VABB cos theta. So this is the magnitude of the relative velocity of A with respect to B. Now if you calculate the direction of the relative velocity, that means when the person B observe A, then the person B thinks, the person B will feel the A is moving at this direction. What is that direction? That direction is the alpha. See, this alpha is the direction of VAB. That means the person B feel that the A is moving along this direction. What is the direction? The direction will defined by the angle alpha. Defined by the angle alpha. Alpha is the angle between A and this relative velocity. So now what is the alpha? Now we'll again use the parallelogram law where the alpha is defined. We for the parallelogram law, from this diagram, this is for the parallelogram law. From this diagram we can write that tan alpha is equal to q sin theta by p plus q cos theta. This is the formula of tan alpha. I hope this already have discussed. So tan alpha is equal to q sin theta by p plus q cos theta. If you compare this diagram with this relative velocity diagram, so the vertical is VA, here the vertical is P. So at the place of VA we put P. And here the horizontal is VA, horizontal is VA, and here the horizontally the vector is P. So at the place of VA, at the place of P we put VA. And here the vertically is VB, and here the vertical is Q. So here at the place of Q we put VB. And here the angle between them is theta, and here the angle between them is 180 minus theta. So here at the place of theta we put 180 minus theta. So in this equation, at the place of Q, if you put VB, and at the place of P if you put VA, so from here we can write tan alpha is equal to VB sine, at the place of theta we put 180 minus theta, so 180 minus theta, again VA plus VB cos 180 minus theta. Student, keep one thing, if parallelogram law is not clear to you, then you cannot understand this one. So before you do, you must revise the parallelogram law. So after that, from here you can write tan alpha is equal to, that is VB sine 180 minus theta. That means we can write sine theta. So here sine theta and by VA plus VB cos 180 minus theta means we know minus cos theta. So here now tan alpha is equal to VB sin theta by VA plus minus minus VB cos theta, that means alpha is equal to tan inverse VB sin theta by VA minus VB cos theta. So this is the direction of the relative velocity, and this is the magnitude of the relative velocity, that means relative velocity of A with respect to B. So here I repeat once more in short. This is the direction of VA, velocity of person A, velocity of person B. So if we extend this B around this direction, that will be minus VB. So this is VA and this is minus VB. The diagonal will be the what? Relative velocity. Relative velocity of A with respect to B. Now we use that means the parallelogram law formula, that VAB is equal to VA square plus VB square plus twice VA VB cos. Here the angle between them A and VA and minus VB is 180 minus theta. So cos 180 minus theta. So here cos 180 minus theta means minus cos theta. So here VA square plus VB square plus minus minus VB cos theta. Now again, if you use this formula to calculate the direction of this relative velocity, the direction of relative velocity is alpha. That means the person B will observe the A is moving along this direction. What is the direction? By an angle alpha with A. So you have to calculate the alpha. Again, if you apply the parallelogram law, the direction, the value of tan alpha, then you can write this one. And this is the direction of the what? Relative velocity of A with respect to B. One thing, at first to revise the parallelogram law, then you can clearly understand these topics. If parallelogram law is not clear to you, then you cannot understand this one. And another thing, suppose this is the relative velocity of A with respect to B. If I give the opposite, the relative velocity of B, if I say relative velocity of B with respect to A, then I draw this diagram. You will do by yourself. This is VA, this is VB. Now here we extend the VA opposite direction. So that will be the minus VA, and this diagonal will represent the relative velocity of B with respect to A. This angle is theta. So what is the angle between this one and this one? That will be again, this angle will be what? 180 minus theta. This angle. And this one is alpha. Again, you have to calculate the VBA by the same process, alpha by the same process, and that will be the relative velocity of B with respect to A. But remember one thing, the magnitude of the relative velocity will be same, but the alpha will be different. So here the person A feel that the person B is moving along this direction. If person A observe B, so person A feel the person B is moving along this direction. So the relative velocity direction is different for these two cases, but the magnitude will be same. So this is your homework. You have to calculate this one.